Welcome, students, to Solving Systems by Substitution. And in this method, which you have done a lot before, even if you didn't know what it was called, you are going to get x or y by itself, then plug that resulting expression into the other equation. And again, right now we're just working with two variables and two equations. We're not doing any three-variable systems. So if you take a look at our first example, this is kind of your ideal situation. Both equations already have y by themselves, so you really don't have to do any extra work. You can get right into the plugging and solving part. So we're actually going to take this dude right here and plug him in right there, because these are both kind of stand-ins for y. Y equals both of them, so we can replace one with the other. Why not? Why not? So I have negative 3x minus 20 equals 2x plus 10. And you guys were just solving inequalities actually with variables on both sides pretty recently, so hopefully that's still in your head. You do need to gather the variables to one side. I personally just like the left side. That's just me. But it really doesn't matter as long as you stay consistent. So I'm going to subtract 2x from both sides. That gives me negative 5x. I'm also going to go ahead in one step. I know I'm going to have to move this negative 20 to the other side, so I'm going to go ahead and do that now without rewriting the whole thing, because that'll cancel there, and that equals 30. So all I did was move the variables to the side, move the constants to the right side. Then to get x by itself, I just divide by negative 5. And I get x equals negative 6. Then you're going to do just like we did on the elimination lesson. And once you find one of the variables, you go ahead and use it to find the second variable by plugging it into one of the equations. So I have my x, now I need to find my y. And I'm going to plug it into, it doesn't really matter, I'll just use the first one. So y equals 2 times negative 6. Plus 10, this is negative 12, plus 10, so that gives me just negative 2, so y equals negative 2. That means my solution to this system of equations is negative 6, negative 2. So this is the point where these lines would intersect, right there. Okay, let's try another one that is not set up quite as nicely. I've got the second equation solved for y. Y is by itself, but the first one is in standard form, but that's actually okay. All you're going to do, since the y is already by itself, is take this expression and plug it in for y. And you would do something similar if the x were by itself. You would just plug it in there. So I'm going to do negative 14x plus 2, and instead of writing y, I'm not going to write y, I'm going to write 7x minus 3, and go ahead and put it in parentheses, because you have to distribute. Okay, so this, just note what happened there. Instead of writing a y, I just stuck that expression in for it, because it's what y equals. And then to just simplify this, I am going to distribute the 2. So I have negative 14x plus 14x minus 6 equals 0. And then I have two x's, or two x terms, so I'm going to combine them. Now in this case, it just so happens that they cancel each other out. So that won't always happen, but when it does, it's kind of nice because you have less work to do. Because then you're left with negative 6 equals 0. And is that true, ladies and gentlemen? No, it's not. It is not true. It is false. It's a lie. So that means this system of equations has no solution. That means that these are parallel lines, by the way. So those are parallel lines. They never intersect. Okay. Third example here. Again, we really want one of the variables to be by itself. None of them are, unfortunately. This one, the x and y are the same. They're actually both in standard form. So the x's and y's are together on the same side of the equation. But look at this one. That x is almost by itself. It doesn't have a coefficient. It's just that this pesky negative 3y is there next to it. So you know what? Let's get rid of the pesky negative 3y. And just add it to both sides of the equation. Then it'll cancel. And then this becomes x equals 24 plus 3y. And then I'm just going to take this expression and plug it in for the x in the first equation. Now don't make the mistake of plugging this into here, because I just transformed that equation. So leave that one alone. Plug it into the other equation. So I got 7, and instead of x, I'm going to write 24 plus 3y, and then plus 2y equals negative 16. Distribute your 7. So 7 times 24 is 168, plus 21y, plus 2y equals negative 16. I'm going to go ahead and combine these together. So 168 plus 23y equals negative 16. Subtract 168 from both sides. And that gives me negative 184. And then finally divide by 23. And that gives me y equals negative 8. And remember, I'm not done yet. I need to find the x value. So go ahead and plug it back into one of the equations. I'm going to go ahead and use this transformed one since the x is already by itself. Just going to save me a step versus using that one. So x equals 24 plus 3 times negative 8. So 24 plus negative 24, which cancels. So x equals 0. That means my solution, where these lines intersect, is the point 0, negative 8.